In the previous lesson, we worked on a ring in Rhino using Grasshopper and created a couple of lofts and ruled surface to do this ring right here. And then we went from the generic shape and we built a structure out of it, and then we baked at the end the results. So just to recap a little bit, this is the first example where well, in this case, we use the Voronoi to create an internal structure, to cut through an internal structure, and then we converted this into a solid using a multi-pipe sub-D node. But previously we divided this into a mesh, so into a series of phases, which can be helpful to define a more precise structure. And this is going to be the topic for this lesson. So we're going to define a grid, and then we're going to place on that grid some details. And we're not going to use like the little fillet, which also it's a topic from the previous lesson. So how to create a precise fillet with two rails and not only with the bevel and fillet and chamfer basic options. So this is an actual sweep, two rail sweep, to make this pretty precise. And once everything is perfectly finished and you don't have like gaps or holes, you can bake everything. And just to show you here that this is the final result here, and it's going to result as a solid once you join everything. So first of all, I want to apply here some material just to see this a little bit better. And so in this lesson, instead, we're going to go like into little details that we can repeat onto the surface. So we're going to talk about repetition, and we're going to talk about distributing and adapting to the surface a little element like diamonds or little studs and things like that. So I'm playing a little bit with the materials here. I'm assigning the material directly from the layer because everything here is on one layer. So you can, when you have like multiple objects, you can assign the material directly to the layer in Rhino. But this part about materials and rendering and lining is covered into the Rhino video course, and also we are creating another course about design and rendering in Rhino, so you can follow up on that. So I'm going to join all the different surfaces here, and when I go into the details in the properties here of the object, there you go. It says closed polysurface. So that's the thing you want to see if you want to print this out with a 3D printer. You want to make sure that everything is perfectly closed. And I'm going to change here into this into a gold effect, so like a yellowish color here for this metal material. So we can see a little bit better with the white background. Well, you can also change the background with the rendering. Again, just I'm going to go quick here, but this is covered into other courses. So you can see here that in the document properties, we have render properties. And here we can also use HDRIs or 3D60 environments. So to make the reflections also a little bit more realistic. Well, this is not yet realistic, but it's better than where we started from. And this is the standard renderer in Rhino. We also have like a more advanced render, which is ray tracing. We're going to see later on. So let's go back to our shape. So what I'm going to do is go to the next layer here and hide the objects that I baked. And I'm going to go back to retrieve this loft right here, which is actually an offset surface, which we offset from an initial loft. And so we're going to use this as a distribution surface. So we need, like, let's say a target where we want to put our objects onto, and then we can choose which thing we want to like distribute or scatter around, again, in a more random way or in a more regular way. We're going to do it regular way this time. So this is chamfer box I just created, and let's go to the deform, transform, and use taper, and let's see what it needs. Well, it needs an axis and it needs a start and an end. So I'm gonna define here, I'm gonna extract here from the base that it's actually using. So this is something you can do. This is why extraction of nodes is useful, because you can reuse them for something else. So for example, this could be my start point, and then I can just define the end point by right-clicking and choosing the set point, and I'm gonna put it up here. So it's gonna go like vertical with like a vertical line, as you can see, and that can be my axis. So it's gonna be like perpendicular in a way to the x and epsilon. And then let's define the start and the end. I'm gonna just put two sliders here, one for the start, and then I'm gonna copy and paste, and I'm gonna use it also for the end. And also in the infinite section here, or parameter, I'm gonna set this on false. So it gives me this result. If I start to slide now, the two sliders, you will see that it's gonna be slightly like tapering. And so again, let's put this on true actually. So now that the taper is more visible. And I also want to change the axis again. I want to go upside down, so from the top to the bottom, so it gets like this. So it gets like a pyramid, like a truncated pyramid. And that's the stud, the single stud. And then we're going to repeat, you know, how many times we want. And I'm also going to put here a box morph. So box morph is to morph the geometry that we need to use, so the surface, into a series of box. So if I plug the initial geometry in here, and then as the target, I'm gonna put this. So okay, let me do it again. So I'm gonna put here the surface box, and I need to use a domain. So I'm gonna put the domain in the domain, and here I'm gonna type slider to define the U count and the V count. This is important, otherwise it won't give me any result. And you can see I'm choosing like a range for this, and I'm avoiding the decimals. Okay, so U count, V count, and then that is gonna go in this surface right there. There you go. So I'm using this surface also here as domain. So I'm dividing the surface into many boxes, and then I can also define a height, because this is too high probably. So you can use another slider to define the height for this. And you can see these are these faces. If we consider this as a grid, it's a little bit stretched. So this is because of how many repetition or division we put in the U and the V direction. So we need to choose this a little bit better, because let me increase the range for the V. So, and so now I can here also, I will increase it a little bit. So you can, you know, change these on the fly where you understand that. And also, they're not supposed to be a lot. You can also put few divisions. Now we'll add a box morph. So box morph will morph anything into a box. And my surface there will be my target, and the geometry will be the stud that I created before with the taper. And it's missing again something, which is the reference. Now for the reference, we want to create a bounding box, and we want to put into the bounding box the geometry again, the stud geometry, and then plug it into the final result. And you can see now it's distributed. So this is the first task, is to distribute. And you can see that where you have like less space, it's going to squash, and when you have more space, it's going to stretch. So you need to find a shape or something that can adapt, and it's also nice to look at when it stretches and when it gets smaller and bigger. And now we can go back here to the number sliders of the divide domain to change this and perhaps fix it, or, you know, make it different. And I've chosen this time